In set theory, we come across certain symbols which are very confusing. We use the same symbol in order to sometimes denote what is a subset, and we use the same symbol sometimes to denote what is a proper subset. In set theory, there are symbols which are very confusing. What does it actually mean? Does it mean the meaning of the first or the second or the both? So in this video, in today's lesson, real analysis lesson number 4, I'm trying to give you a complete clarification and avoid all the confusions which are related to set theory, how the symbols are, and can we use the same symbol for both the meaning, or do we have a better approach? My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to freshman course in real analysis lesson number 4, where I would try to clarify certain confusions with the symbols in set theory. So before we go ahead, I would like to quickly recap for those who have missed and what was basically taught in the earlier lesson, a bird's eye view. So we started with understanding what is a union. We gave certain examples, intersection, disjoint sets, and we started also with subsets. And we found that subsets has got a lot of functionalities and a lot of variation. So we first saw how to calculate subsets of a set. Then we found what are the subset symbols, what is not a subset, what is a proper subset, and how to calculate a proper subset and which is not a proper subset. We gave examples and we tried to find out what are the symbols. We also tried to find out what is an improper set. Then we moved to superset and we found out what is not a superset symbols for that, what is a proper superset, what is not a proper superset, and what are the superset symbols. Now in this video I would be talking a little bit about subsets and supersets and what are the confusions that are created using the symbols. Okay, so first we will start with what is called basically a subset. Now you see this is a symbol which is used in subset, and we denote the meaning is that subset has few or all elements equal to the set. So the bar below is basically signifying something which is equal to. So 7 and 15 is a subset of 7, 13, 15, 21, because certain numbers are always equal to, right? A is a subset of B, which means set A is included in set B, and it is used to denote containment of sets. So as you see, this is a subset of this and is a subset of real numbers. Now we use this one to denote what is called a proper subset or a strict subset. Now strict subset means obviously it will be a subset which has got fewer elements than the set. So you see 7, 13, 15 is a proper subset of this because it has got 7, 13 and 15 with some extra elements. Similarly with this, A is a subset of B, but A is not equal to B. So that is why you see the horizontal line is not given. So this one, A is a proper subset of B if and only if A is a subset of B and most importantly A is not equal to B. So these things we know what is a subset and what is a proper subset and the symbols. Now what is the confusion? Now we can use this symbol also to denote a proper subset. Now it used to denote a proper containment of set. That was just a containment of sets. This is a proper containment of sets. So we can say this one is a proper subset of this. This one is also proper subset of this, but this one is not, because this set, the n numbers, won't be a kind of a proper subset of this. Now the confusion starts with this symbol, which is a kind of a the proper subset. Now this symbol is ambiguous and I would request to avoid it. Why? I will just tell you coming up in this part of the video. Now you see this symbol is actually used to denote both proper subset, which means A is actually a proper subset and of B and A is not equal to B. But in some books, mathematicians and certain textbooks also uses to denote any subset, means which is equal to and not equal to. It can be used for anything, and so I would recommend you to use better this one, which actually means a proper subset and it shows it not equal to, or you can use this one also, which carries two equal to and a not equal to sign. And remember that this sign is also used for improper subset. Now this is basically the confusion. So some books use this one as proper subset, any subset. So the best way to avoid the confusion is to use the bottom denomination with a straight line with a not equal to sign. Okay. Now we come to another confusion, which is the superset. Now we know this is a superset, and we know this is also a superset. Sometimes both these are used. So if we say S is a superset of T, what I'm trying to mean is that S is a superset of T, or equivalently T is a subset of S. Now in certain books, this symbol and this symbol, both of them are used as superset, right? Okay. So this symbol, what I am trying to tell is that this superset symbol can be used both for this, right? And this actually means read as a superset or equal to, right? So this one is sometimes used as superset or equal to something, right? So this is a kind of a confusion which I'm trying to clear. So read as superset or equal to, or sometimes simply a superset. This symbol is also used in this, which actually means as superset of, but this means it represents strictly superset of but not equal to, right? Right. So this is something which I want to. So some books will use both the symbols and superset, and the superset also means sometimes this symbol which is meant for superset of, and this one is not equal to, right? This one is equal to, but this one is not equal to. So what I would suggest is that, for example, if we use an example like x equal to set of triangles and y is equal to set of obtuse triangles, then the x is the superset of y, because obtuse triangles are classified obviously under the type of triangles. So it can be denoted as either this one, right? And it actually means improper subset is also represented as this, where x may or may not be equal to, or it can be represented as this, which shows that proper subset is represented by this, where this means actually x is strictly not equal to, right? So these two things should not be confused with each other. So what I can tell is that this one is actually used for proper superset. I would say recommend this one or this one. Same as subset, right? You can use a straight horizontal line and a not equal to sign. Why I'm saying, because both here it means S is a proper subset of T and S is also a proper subset of T. I mean to say both means S is a proper superset of T, right? In other words, we can say that this one actually and this one, just a second, yeah, so it actually means this one. In other words, S is I would say a proper superset of T, and S would not be equal to T, right? So this one and this one would be the same. Here it says S is actually a proper subset and S is actually not this one for superset of T, right? Okay, can we summarize what we have learned today? So we know that this one is used for subset, this one is used for proper subset and strict subset. This one is a proper subset used to denote containment of sets. This one we will try to avoid. We will do this and this, which actually is better to use. We also know the superset symbol has two signs, this one, and we will use this one for to use denote proper superset. So the subset and superset, more or less they stand the same, only it is better to use these symbols and to try and avoid confusions. Thank you for watching this video. I believe that I have been able to give you a better clarity on the confusions which are created. And if you like this channel, please subscribe to Physics for Students. Click on bell icon to get all the notification from Physics for Students. You can click on you can contact me through this email ID and subscribe to my other channel, and you can follow me on my Instagram, Facebook and LinkedIn pages. Thank you for watching this video. I will be soon back with few more videos on sets, and then we will jump into the real problem of real analysis. Thank you very much for watching this video.